So to describe the challenge and the solution we applied, we have to think about what kind of factory Devold is. And as we know, it's a textile factory, and there's been a lot of solutions that is sort of historical and inherited. And the way they do, for example, intralogistics in the factory, it's still done today by the same methods as it was done 50 years ago. So people are moving garments or pieces of garments on trolleys between different sewing stations where different operations are performed. And of course this is quite challenging. It's a lot of manual labor, and you have to think how you do this. And the other problem that we have encountered is actually that because of a lot of pieces from these garments that can actually get into the wheel systems, and because there is still a lot of human traffic in between these operators, we could not really apply a sort of driving or an AGV or an AMR solution. So we really had to come up with something that was rather novel. So that was the reason why we invented the overhead system. Our utilization of the Opel platform really started from trying to build up the factory setup in terms of the ground floor, and in the beginning we also tried to have the logic built in and see what kind of sensor nodes we would have, the robot nodes, to see really how the general user interface or the HMI component would work. And it really took us some time to get it all working, but once we sort of clamped it all together, and we could really start seeing the benefits, especially of the data traveling between our robot platform and the different modules that Opel was providing. We were also seeing the real-time travel coordinates of the robot. We could actually see many other things on our user interface, and of course we really tried to investigate and use the route planning or task planner module, which I think is a fantastic idea. The whole setup is really something that a sort of intralogistics solution provider can really sort of use to build a solution or a model of the system really fast, and we really try to have all of these components very well connected and tested. If you use the right set of tools in the right order, you can really save a lot of time just by modeling the processes, seeing how they would work in reality, without actually having to go in the reality. So we actually did some small mistakes, but I think the biggest learning is that you have to use simulation and digital twin platforms like Opel to really simulate that, and that is very useful, both for the manufacturing companies and both for technology providers like us and other partners. And it also helped us to get together, because the goal to get together closer, because the goal of the project that we're building together is actually to build a system that both Devold can utilize, but also to provide it later to other players in the market who would also benefit from that. So I think the whole setup really helped us a lot to push the project much further and provide a better quality to the end customers, which will be joining later after Devold.